In section 5 of chapter 10, we are now going to be utilizing those 7 properties of logarithms to now solve logarithmic equations. We kind of already did it in the last section, but this section is completely dedicated to it. And there's another little hiccup to it that you probably forgot about, but we will go over again. I only got 1 slide worth of problems. 3 questions. I am going to solve all 3 of these exclusively using those 7 properties. Problem number 1, I have the natural log of the quantity 2x minus 1 quantity plus the natural log of 5 quantity equals 3. If I want to solve that equation, I'm going to have to get the x by itself. The x is inside of a logarithm. That is not where variables belong for logarithms. So I'm going to have to convert it out of a logarithm. In order to convert it out of a logarithm, I need to be a single logarithm. Right now I have 2 logarithms that are being added together. So that's my first hurdle. I need to turn those 2 logarithms into 1 logarithm. I'm going to use property 4 because property 4 deals with the sum of 2 logarithms and how we can combine those into a single logarithm as long as we multiply their insides together. 2x minus 1 times 5 is 10x minus 5. For some reason, students tend to forget to multiply that 5 to both parts of the 2x minus 1. They'll just say it's 10x minus 1. Don't forget to distribute. Equals 3. Now that I got my logarithm by itself, I can switch it from logarithmic form to exponential form. Remember, that is going from a to the b power equals c, converts into or converts from log base a of c is equal to b. Right now we have the logarithm on the right. We want to convert it into the exponential on the left. It is not written, but the base of this logarithm is an e. Natural log, ln, means that you have a base of e. We just typically don't write it. So this problem is going to turn into e to the 3rd power equals 10x minus 5. I would then add 5 to both sides, leaving me with 10x equals e to the 3rd plus 5. I would then divide both sides by 10. Kind of running out of space, but I'll just write it off to the side. That means x is going to equal e to the 3rd plus 5 all over 10 as my final answer. Problem 2 is similar but different because problem 1 has a logarithm equals number. Problem 2 has logarithm equals logarithm. We're still going to condense those 2 logarithms on the left into a single logarithm, but we're going to do something different in the conversion process. So this is utilizing property 5 because I'm subtracting 2 logarithms. Those will combine together through division of their interiors. So this will become 2x divided by 3. And that is equal to log base 7 of 8. Now if you want to utilize the format to transform from logarithmic form to exponential, that will work. Nothing is wrong with that. You're just going to give a problem that takes a couple more steps because then you have to utilize property 6. However, if you have a log base 7 equals a log base 7, the only way that that can be true is if their interiors are equal to each other. Therefore, this problem transforms into 2 to the x over 3 equals 8. Get rid of the 2 over 3 by multiplying both sides by 3 over 2. The 3 and the 3 will cancel. The 2 and the 2 will cancel, leaving you with just the x. This is an 8 over 1. 2 and the 8 would cancel, turning that into a 4. 4 times 3 is equal to 12. 12 divided by 1 is just 12. There is my solution. Problem 3 is the one that I guarantee you a bunch of you are going to get wrong on the test. You're going to get it wrong for a couple of reasons. 1, this is kind of a complex problem that's going to involve factoring. And 2, it's something that we're going to do at the very, very end. Problem number 3, we have log base 4 of x plus 5 plus log base 4 of x plus 11 equals 2. I'm going to combine those 2 together using property 4 because we're adding 2 logarithms. This is log base 4 of x plus 5 times x plus 11 equals 2. I'll switch this from logarithmic form into exponential form. This is 4 to the 2nd power equals x plus 5 times x plus 11. I will multiply those out. 4 to the second power is equal to 16. And then x plus 5 times x plus 11. First term of the first binomial times the first term of the second binomial. X times x is x squared. First term of the first binomial times the second term of the second binomial. X times positive 11 is 11x. Second term of the first binomial times the first term of the second binomial. 5 times x is 5x. And then lastly, second term of the first binomial times the second term of the second binomial. 5 times 11 is 55. I'm going to run out of space just a little bit, so I'm going to do my next step up here. I'm going to subtract 16 from both sides. That'll leave me with 0 equals x squared plus 16x plus 39. Now that I have this all multiplied out and equal to 0, now I can factor. Just when you thought factoring was done, it rears its ugly head and it is back again. You can factor this using whatever technique you want. You can use the area model, tick-tock method, diamond method, old school method. You could use the quadratic formula, completing the square. At this point, it's up to you. But once you factor this, it'll turn to 0 equals x plus 13 times x plus 3. Set each of those equal to 0. And solve. Subtract 13, subtract 13. Subtract 3, subtract 3. X equals negative 13. Or x equals negative 3. And one of those answers is wrong. Negative 13 is not a correct answer. Negative 13 is not a correct answer because if you substitute the negative 13 back into the original equation, negative 13 plus 5 is negative 8. One of the rules I told you at the beginning of this chapter, the interior of a logarithm is never, ever allowed to be equal to or smaller than 0. Because remember, the interior of the logarithm is the solution to the exponential. That's the same thing as stating, if this is negative 13, this is me asking 4 to what power is equal to negative 13. That doesn't exist. You can't have a 4, a positive 4, bring it to a power, and then suddenly it produces a negative number. You can't have a positive number multiply times itself a certain number of times and produce a negative value. That doesn't exist. For logarithms, you must make sure the interior is positive. So just like in the past when we check for extraneous solutions, one thing you can kind of do off to the side is you can list the extraneous solutions. For this one, x has to be greater than negative 5. Here, x has to be greater than negative 11, and that is our limitation. X has to be greater than negative 5. This is our, if you want to call it the discontinuities, that is our domain restriction. Negative 13 does not pass that. However, negative 3 does. This only has one solution.